So in this video, we're going to talk about what we call measures of position and variation. And when we talk about position and variation, what we're really talking about is how spread out our data is. So we've looked at the mean and the median, which were center measures, telling us typical values of the distribution. Now that we know those typical values, I want to know how far are the other values in the distribution spread out from that. And when we talk about the variation measures, we already know one measure of variation, which is called the range. And the range is the simplest of all the variation measures to find, and it's equal to our max value minus our min. The problem with the range, though, is it only takes into two measures, and those are the max value and the min value. So we can have very large ranges and only know two things about it, which doesn't tell us a whole lot. A better measure and a more detailed measure that we have is called the standard deviation. And we're going to find the standard deviation through a process, and that process is going to involve us taking things and squaring. And when we square that standard deviation, we get what's called the variance. So we're going to talk about both those measures next. So when we talk about the variance and the standard deviation, the first thing I want you to understand is what the standard deviation is. And the standard deviation is very much like a mean for the center value. So standard deviation is the mean for the spread values now. And remember, the mean takes into account every value. You have to add up every value and then divide by the total. Well, the standard deviation looks at every value and talks about how far it is from the middle value. And by definition, the standard deviation is the average deviation from the mean. And let's try to break this down to actually find the standard deviation. Because when we talk about a average deviation, well, what is a deviation? In the case of statistics, a deviation is how far a value is away from the mean, or the difference from the mean. So our deviation is equal to some observation, which we'll call x, subtracted from the mean, which we call x bar. So this tells me how far x is away from the mean. And if x is smaller than the mean, then this value will be negative. If x is bigger than the mean, then this value will be positive. So deviations can be positive or negative. And what happens is I want to find that average deviation. And so I'm going to go through this process of finding that average deviation. And when I do that, you'll see that if we find the deviations, and if the mean does its job like it's supposed to, the actual deviation itself from the mean should be a particular number. So let's look at an example. So in this example, it says the following scores are a sample of test scores on the first test in this class. Find the standard deviation for the test scores. If we want to find the standard deviation, the best way to do this is to actually use the definition of standard deviation. And we call the standard deviation of a population. We call that, this is the Greek letter sigma. And this is equal to the population standard deviation. We're finding the standard deviation of a sample. And how do I know that? Well, it tells me that I'm looking at a sample of test scores. So these are different. They're the same concept, but they're different values. The population standard deviation looks at every value. The sample standard deviation, which is what we're finding right now, only looks at a sample. So we have 6 values here. So our sample standard deviation is called S of x. This is what we call the sample standard deviation. Now, to find the sample standard deviation, again, we're going to use the definition of standard deviation. And remember, standard deviation is just the average deviation from the mean. So keep that in mind. We're finding the average deviation from the mean. That means in order to start this process, the first step I'm going to do, here are my steps. The first step is to find the mean. And we're going to find the mean of a sample, so we call that x bar. And when I calculate x bar for this sample right here, the sum of these values, when I add up all 6 of these values, I get 450, and I'm dividing that by 6. So x bar is equal to 450 divided by 6, which is just 75. So the average score for this class, or for this sample of data, is 75. Once I know the average, I'm going to find the average deviation from the mean. So I have the mean, I want to find the deviation from the mean next. So the second step is to find the deviations. And to find a deviation, this is just x minus x bar, where x stands for these different observations and x bar is the mean. So our deviations go like this as follows. The first one would be 57 minus 75. If I do 57 minus 75, I get a negative 18. The next observation is 64 minus 75. Subtracting that, I get a negative 11. 72 minus 75 is equal to a negative 3. Now, the next three observations are all bigger than the mean, so they will all be positive values. So if I do 82 minus 75, I get 7. 84 minus 75 is equal to 9. And then 91 minus 75 equals 16. And here's what happens. If we want to find the average deviation, remember the average deviation. Well, how do I find an average again? I'm going to take all these deviations, add them up, and then divide by their total, which is 6. The problem with this, though, and here's what happens, and here's what should happen, is that when I add up all these values, negative 18, negative 11, negative 3, 7, 9, and 16, it's going to give me the number of the sum of these deviations is equal to 0. And if I try to take the average of a number like 0, well, then I'm just going to get 0. So that doesn't tell me anything about the data. Well, why does this occur? And it occurs because the mean is doing its job. The mean is a balancing point. And so the mean 75 sits in such a way that when you balance, it's going to equal 0. So in order to fix this, because we can't find the average of 0, we take each one of these values and we square them. So we're going to go through and square all of these deviations. So when we square the deviations, so I'm going to take the deviations and I'm going to square them. And negative 18 squared is equal to 324. Negative 11 squared is equal to 121. Negative 3 squared is equal to positive 9. 7 squared equal to 49. 9 squared equal to 81. And then 16 squared is equal to 256. So when I go through now and add all of these up, the sum of the x minus x bar squared, the sum of the deviation squared is equal to 840. By definition, the standard deviation, again, it is the average deviation from the mean. So what we found is we found the sum of the squared deviations. If I want to find that average now, all I have to do is take this and divide it by the total, which is 6. So I'm going to divide 840 by 6. When I divide 840 by 6, I get 140. This is an average, but it is the squared average. It is the square deviation average. And that's a problem because we can't talk about, for instance, test scores in terms of a square. What is a scored test score? It doesn't make any sense. So to fix this, if I don't want the square, I can undo squares by taking the square root. And when I take that square root, I'm getting what's called my standard deviation. And this is what we call sigma x. And so sigma x is equal to the square root of, in this case, 140. And the square root of 140 is just 11.832. Now, that process seems long, but again, it was very straightforward if you use the definition. And again, the definition just says the average deviation from the mean. So I used that entire definition to find this. I found the mean first, which was 75. Then I started finding the average deviation from this value. When I tried to find the average deviation by just adding deviations like this, I got a 0 value. To fix it, I had to go and square those deviations. So once you have your deviations, you square them. And once they are squared, you get a new value called the variance. And remember, this number right here that we're getting from the square deviations, and this is the average. It's the average from dividing by 6. The average of square deviations was equal to 140. So this right here is what we call our variance. And we call the variance sigma squared x, because it is the squared of the deviations. The problem with the variance, though, is that it's a squared term. And in terms of context, squares make no sense because you can't have squared scores, or you can't have like squared money, or you can't have like squared measurements in other things, in days, for instance. You can't have those type of units. So to fix that, we go ahead and we take the square root. And when we take the square root of this squared term here, we get our standard deviation. So both these values are how we get to the end value, which is the standard deviation. Now, the biggest problem with both these values, the standard deviation and the variance, the way we found them, is that we're assuming that we're finding a population value, and we aren't. And in general, most times you won't find population values. You're going to find sample values. Populations assume you know everything, which means you can be very precise. In a sample, you need more error because you're not grabbing every value. And because of that, we need to add more error into our measurement. So we do that by changing this number that we're dividing by here. And we're going to change this 6 and make it a smaller number. And by making it smaller, it makes the actual error measurement bigger. And so when we do that, here's going to be the formula that we're going to use. Instead of dividing by 6, we're always going to divide by 1 less. So everything else is found the exact same way. And when I say that, I mean that we're going to first find the mean of the data set. Then we're going to find our deviations. We know that when we add all these deviations, they add up to 0. So once we see they add up to 0, we're going to go back and square all the deviations. Add up all the deviations, and that's going to give us this top number, 840. We divided by 6 because that was the population that we assumed we were finding. We're not finding a population because we said it was a sample. Because it's a sample, we're going to divide by 1 less. So the sample standard deviation, or the sample variance is where we start with. The sample variance is equal to s squared x. And the sample standard deviation is equal to s of x. And so to find the sample standard deviation, I'm going to take that 840, and instead of dividing it by 6, I'm going to divide by 1 less, which is 5. And the reason I do that is because when you divide by a smaller number, it makes things bigger. Mathematically, that's what happens. Think about sharing pizza with a friend. Which slice is larger, when you share it with 2 friends or when you share it with 3 friends? You get a larger slice if there's less people. So a smaller number will always make this value bigger. And so when we divide 840 by 5, I get a value that instead of, remember when I did 840 divided by 6, I got 140? Well, 840 divided by 5 is now equal to 168, which is a much bigger value than I'm going to take a square root of now. And this is the sample variance because it's the squares that we just found. We took these values right here. Instead of dividing by 6, now divided by 5, 1 less. And when I do that, now I can find the standard deviation by taking the square root of 168. And when I take the square root of 168, I get 12.961, which if we compare this value right here to the population value, it is bigger. Our sample standard deviation should always be bigger, and it's the value that we actually want to calculate. Now, I've shown you how to do this by hand, manually through all this, and I haven't given you the formula yet. So now I'm going to give you the formula for this particular standard deviation. The standard deviation, also known as S of x, which is the sample standard deviation, is equal to the square root of, using the definition, we have to find the average deviation from the mean. So a deviation is x minus, and I want to be away from the mean, we call the mean x bar. It's x minus x bar. So this first part says to find the deviation. That's what the deviation is, x minus x bar. We know when we do that, and then we're going to add them all up to find the mean. If I add them all up, do I get 0? So how did I fix that? Well, I square it. And then I'm going to divide all of this. The top now says x minus x bars, the deviations squared, add them all up with sigma sum means, divided by the total will be the average. But for a sample, I need to divide it by 1 less, so this will be n minus 1. So this is how we find the sample standard deviation, and this is the entire process. And it looks like a lot, and the more you practice, the easier it'll get. But the best thing about this is that we have technology that's going to get it for us most of the time.